Dear students, good morning, good afternoon, and good evening. Based on the time zone that presently you are staying. First of all, I welcome all of you for our YouTube channel. You know very well, I am Selvamani Krishnamurthy, who is sitting in front of you. This is Machine Learning video lesson number 11. In this lesson, let us study support vector machine. One more classification algorithm for supervised learning. Support vector machine is a supervised learning for classifications algorithm. So as usual, I like to share my screen. I hope my screen is visible to all. See, this is machine learning for beginners, lesson number 11. Topic is supervised learning, support vector machine classifications. That is what we are going to learn. So first let us study what do you mean by support vector machine, how it works. Then we can go for how to create one model for support vector machine. Then we can make them to train and then we can test the output. See, the goal of support vector machine, simply SVM algorithm, is to create the best line of decision boundary. This decision boundary, we can call it as best line or hyperplan. That decision boundary or hyperplan that separates different classes. Assume we have output two number of output, category 1, category 2, or class 1, class 2. This class 1, class 2 needs to be separated. That means we are drawing on hyperplan or best of decision boundary. Left side of the hyperplan should be class 1. Right side of the hyperplan or class 2. Like this, we need to separate. So what are the steps involved in support vector machine? We have one data set. The data set has so many data points. Mark each data point. Each data pair or data point of data set is said to be vector. Mark each data point of data set in multi-dimensional graph. For simple purpose, we can take two-dimensional graph. No need to worry about multi-dimensional, two-dimensional graph. That means x-axis, y-axis, where each dimension represents each feature. For simple process, we can consider only two features. Feature 1, feature 2. Feature 1 or column 1 or input 1 should be mapped on x-axis. Feature 2 or column 2 or input 2 should be mapped on y-axis. Data point means xy point should be marked in this graph. Second step is find a hyperplan. This is called as best line of decision. Find a hyperplan which effectively separates the data point of different classes. Now we need to draw one hyperplan which should separate two different classes of data point. At the same time, maximize the margin between the two different classes. Vector support vectors are a data point that lies very much close to the hyperplan. See, these steps let us explain with the help of one diagram. See, this is x-axis. X-axis mapped with one input x1. Similarly, y-axis is mapped with another input x2. That means we are having two features, one input 1, input 2. Fine. Now, these are the data point. Those are marked by green color as well as marked by blue color. That means we have two different classes of output. Class 1, class 2. Okay. See, class 1 are marked by green color. Class 2 are marked by blue color. In between these two categories, I draw one small line. This line is said to be hyperplan or best line of boundary. The point which are very much close to hyperplan are said to be support vector. This point of category 1 is very much close to hyperplan. Similarly, this point is very much closer to hyperplan. So these 2 points are called as support vector. If we get new input x1 and x2, if its point lies right side of this hyperplan, we can simply call it as this data point belongs to category 2. If the same point lies on left side of the hyperplan, we can call it as this data point belongs to category 1. Very simple. This is called as support vector vision. Now let us proceed for one small coding. Before that, let us consider one data set. See, we have one data set to create support vector mission algorithm for the following data to predict the customer will buy our product or not based on the customer age and customer estimated salary. That means in this case, we can consider age and estimated salary as input, purchased as output. We have one data set. The data set contains 5 columns: user ID, gender, age, estimated salary, and purchase. In this, no need to worry about user ID and gender. Let us consider only age, estimated salary, and purchase. Out of these 3 columns, let us consider age and estimated salary as an input, purchased as an output. Our aim is that customer will buy our product or not. So age is there, estimated salary is there. Just simply let us go through. Age is 19, 35, 26 like this. Expected salary 19,000, 20,000 like this. Purchased 0, 1. 0 means that customer didn't buy our product. 1 means that customer bought our product. I hope so far clear. Now let us create one small coding. As usual, import pandas as PD. We are creating one small data frame from item underscore purchase.csv file. Now df is a data frame which is created from one CSV file called item underscore purchase. The reason is our data frame contains 400 rows and 5 columns. 5 columns already we studied: user ID, gender, age, estimated salary, and purchase. 400 rows it has. Fine. Let us see only top 5 rows with the help of df.head. See, this is top 5 records. Just go through this record. You can easily understand 19, 35, 26, 27, 19. Purchased 0, 0, 0. That means those are younger age. That means less or equal 35 years old. Didn't buy our product. Didn't buy our product. That means those are younger. Didn't buy our product. Okay. Let us go for last 5 record df.time. Again, go through this record 46, 51, 50 like this. Those are above 40. That means somewhat aged person. Their salary is less, their salary is maybe more. That's not a problem. Those are older, bought our product. Simple logic, we can understand this one. Good. Now let us proceed how to separate input and output from the data frame. As I said before, age and estimated salary can be considered as input. In this data frame, age is a second column, estimated is a fourth column. That means I need all rows of third column and fourth column as input. I create another data frame called input. This input is only second column and the third column of df data frame. So df.ilog of all rows I need, but only second column and the third column. That means age, estimated salary, all rows I want. Creating input with age and the estimated salary. Input.get. So 400 rows with only 2 columns, age and estimated. So input.get shows top 5 rows only. See, age 19, 38, 26, 27, that is. In same way, let us create output. Output is what? This only purchased column. 0, 1, 2, 3, fourth column only I need. All rows of fourth column should be considered as output. See, output equal to df dot I log of all rows comma fourth column. So this statement creates output with only purchases. As usual, output dot get, yes, display. So input we created, output also we created. Now the problem is we need to divide our data set into two parts. One is training set, another one is testing set. Already we know very well from sklan dot module underscore selection import train test split. This train test split module is available under sklan model selection. It has one method called train underscore test underscore split. So it splits the data set into two parts. One is training data, another one is testing data. So this method gets three arguments: input comma output comma text size equal to 0.25. That means 75% of the rows, 75% of the data point will be considered as training data set. Remaining 25% of the data set should be considered as testing data set. So here we got four data frame: X train, X test, Y train, Y test. X should be considered as input, Y should be considered as output. Let me check here. X underscore train dot shape. It contains 300 rows, 2 columns. 300 rows of 2 columns means age and the estimated salary. 300 rows, only 1 column. That is Y train. That means 300 rows of purchased output. 100 comma 2. That means what? Testing data. 100 rows of 2 column. Testing input. 100 comma only 1 column. That means testing output. So everything fine. Now let us create a one support vector machine model. From sklan.svm, import capital SVC. So this capital SVC is a one module available under sklan.svm. SVC is a short form of support vector for classification. Here we are creating one object under SVC class. In this case, svmc underscore model is a one module for support vector machine for classification. So model is successfully created. After that, we need to train the model with the training data set. We have training data set S underscore train as well as Y underscore train. X underscore train is a input of training data set. Y underscore train is a output of training data set. Both I gave. Now our model support vector machine for classification model is properly trained. It is ready to predict new values. See it here. Module svmc underscore model dot predict. I gave first 1 comma 10,000. That means the person customer age is only one, very, very small one. He is earning 10,000 rupees. It is illogical, but we will test try. Age is 1, salary is 10,000. Surely you can easily say he will not buy our product. So that is why I got 0. Next data set is age is 19, a customer with 19 years old and earning estimated salary of 19,500. Age is very small. Again, he will not buy our product, 0. See the third data point. Age is 57, 61,000. That means a customer who is 57 years old, earning 62,000. So normally he will buy our product. That is why I got number 1. So our model predicted correctly for new data point also. Good. But in addition to that, how we can find out accuracy? How much our model predict the value correctly? This is called as accuracy. Already we have testing data. With the help of testing data, we can predict new values. See it here. svmc underscore model is a support vector machine model. Predict X data. 100 rows with 2 columns. Okay, is predicted. So Y predict is a predicted value given by our model. Out of these 100 values, I want to see only top 5 values, 0 to 4. See 1, 0, 0, 0. This is the predicted value by our model. But what is the exact output for testing data? See it here, Y test is here, output of testing data, 1, 0, 1, 0, 0. Here 1, 0, 0, 0, 0. That means our model predicted 1, 0, 0, 0, 0. But exact output testing data is 1, 0, 1, 0, 0. That means what? Out of these 5 times or 5 data points, our model predicted 4 times correctly. In one time, it failed. So most probably our accuracy is around 80%. That means out of 5%, 5 data point or 5 inputs, our model correctly predicted 4 times. So the accuracy of our model should be around 80%. Let me check from sklan input matrix. Matrix dot accuracy underscore score. Y test comma Y predict. Finding accuracy of the model. It shows 0.83. That means approximately 80% accuracy is there. I hope it is clear. Let me demonstrate the same thing in front of you so that you can easily understand. I open my Jupyter notebook. So first I need to upload our CSV file, item underscore purchase.csv file. I click it here, upload. So my file is available in E drive. Item underscore purchase. See, this is what our CSV file. So upload. Our CSV file item underscore purchase is uploaded. Now let us proceed for notebook. As usual, import pandas.pd. That's as pd. I need to create one new data frame. Underscore CSV. Our CSV file is item purchase.csv. Let me check the shape of the data frame. It should be 400, 5. Top 5 record, let me check. So it shows shape of the data frame is 400, 5. That means our data frame contains 400 rows, 5 columns. Top 5, that means topmost 5 record shows. In same way, let me check bottom 5 with the help of tile. So it's a, let us go through this data frame. Those are younger age, irrespective of their salary, they didn't buy our product. Those are older, irrespective of their salary may be less or more, that's not a problem. If they are older, means they are buying our product. Good. So now, let me create input and output. As I said before, age and the estimated salary. Second column and the third column is input. Let me create another data frame called inputs. Let us extract only second column and the third column. That means all rows I need, but second column, third column only I want. So let me check it. So second column and the third column only I accepted as input. In same way, I need to create output ef.ilog all rows I want, but only fourth column, that is purchase. Put dot get. It should be colon, not semicolon. See, I got output. So now input and outputs are ready. Now we need to separate the training data as well as testing data. So for that, we need to import sklan model underscore selection. Import train underscore test underscore split. Now, for data frame, it will create. First one is X train. Second one is X test. Third one is Y train. Fourth one is Y test. Good. Now our method is train underscore test underscore split. It accepts three arguments: inputs, comma, output, comma, test size. I'm giving test size 0.25. That means 75% of the data frame of input and output belongs to training data set. Remaining 25 belongs to testing data set. Let me check. So far, no problem. Let us check the shape of each data set. X train dot shape. Similarly, Y train shape. Same way, X test dot shape, comma, Y test dot shape. Let me check. So 300 comma 2, that is X train. 300 comma 1, that is Y train. 100 comma 2, X test. 100 comma 1, Y test. So far, no problem. Now, next step is we need to create one support vector machine classification algorithm. Okay, dot svm, capital SVC. Good. Now we need to create one model SVMC model equal to SVC. Kernel should be linear. Within single quotes, linear. We created one module. Let us train the model. Model dot fit. The model with the training data set. X train, comma, Y train. Let me check is properly trained or not. So in this line, we are creating one model. In this line, svmc underscore model dot fit. We are training the model with the help of X train as well as Y train. With the help of training data set, we are training the model. Let us wait some time. So since we have around 300 record, it takes some time. See, now our model is properly trained. So now it is ready to predict for new values. Okay. Now see SVMC underscore model dot predict. First, I gave 1 comma 10,000. That means the customer age is 1, his salary is 10,000. What will happen? It returns 0. That means he will not buy our product. Then I gave another customer age is 19, 19,500. So young boy, again he will not buy our product. Third term I gave age is 57, salary is 61,000. So elder person, he will buy our product. That is why it returns 1. I hope it is clear. Since now, let us see the accuracy of the module. See it here, y predict equal to svmc underscore model dot predict x test. Already 100 records I reserved for testing data. With the help of testing data, I want to predict new 100 outputs. That new 100 output will be stored into y underscore predict. Now we got 100 output. Out of 100 output, I want to see only top 5, 0 to 4. See 1, 0, 1, 1, 1. Already I have testing data, y underscore test. Now I want to display y underscore test data. Now let me check. Good. Again, I got the testing data, 1, 0, 1, 1, 1. Now you can compare this predicted value as well as testing data, output data. More or less same, only one value is changing, no problem. Now, what about the accuracy of our module? How we can find out? See it here from sklan import metrics. So metric is a module which is available under sklan. Fine. So metrics dot accuracy underscore score y underscore test comma y underscore predict. So these two value, testing value as well as predicted value, I gave as an argument for accuracy underscore 8. So now it gives 0.84. 0.84 is approximately close to 80%. So our module correctly predicted 8 times out of 10 times. That is why our accuracy is 80%. So today, let me stop here itself. I hope today's lesson is very much interesting. All of you understand clearly. In next lesson, let us study something extra. Until then, thank you, student. Have a nice good day. Bye bye. See you.